This lesson is Vobs, or variables on both sides. The essential question here is how can you solve an equation that has variables on both sides? The core concept here is solving equations with variables on both sides. To solve an equation with variables on both sides, or Vobs, simplify one or both sides of the equation if necessary. Then use inverse operations to collect the variable terms on one side and then collect the constant terms on the other side and isolate the variable. Remember, inverse operations are the ones that are opposite each other, so add, subtract, or multiply and divide are inverse operations. And collect the variable. Variable means it has the letter in it, and constant does not. It's only the number. So let's look at our first example here. 10 minus 4x equals 9x. One thing I always like to do to help start out is I'm just going to draw my line going down the equal sign. And remember that you have to do to one side the same thing you do to the other side. So if we're looking at what we need to do is we need to try to figure out how to isolate the variables. Because right now I've got an x on both sides of the equation. So what I'm going to do is I'm going to add 4x here. Because that's going to get it so that the variable is no longer here. So I'm left with 10 on this side, and negative 9x plus 4x is going to be a negative 5x. So now, our next step is to look at this. How am I going to isolate the variable? Again, by doing the inverse operation. Right now, negative 5 is being multiplied by x, so I need to divide by negative 5. Those will cancel out, and I'll be left with just x on this side. And 10 divided negative 5 is negative 2. So x equals negative 2. And you can always check your solution by putting it in. We've got 10 minus 4 times negative 2 equal to negative 9 times negative 2. So we have 10, negative 4 times negative 2 is 8, and negative 9 times negative 2 is 18. So we have 18 equal to 18, so it checks out, and our solution is correct. So let's look at number 2. Our example 2 here looks quite complicated here. We've got grouping symbols too. But remember, we're just got to follow the same steps. Just draw your line. First thing we're going to do is we're going to simplify everything and get everything distributed out. So if we're going to look at this here, we're going to pass this 3 out to both terms. So we're going to end up with 9x minus 12. Now again, on this side, we're going to pass the 1/4 to both terms. So 1/4 times 32x is going to be 8x. And 1/4 times 56 is going to be 14. So now we've got 9x minus 12 equal to 8x plus 14. So now we've got to figure out how are we going to isolate our variables. Well, I'm just going to pick one side. I'm going to subtract 8x from this side. Whatever I do to one side, do to the other. So that's going to eliminate that, and I'm going to have 14 over here, and I'm going to have x minus 12 over here. Now again, I'm not done yet because my x is not isolated yet. It's not all by itself. We're subtracting 12 over here. So we need to add 12 to both sides so that we can find that x is equal to 26. Now you can plug in 26 into this equation and you should find that it is correct. So when we're looking at our core concept here, our special solution of linear equations, equations do not always have one solution. So far we've gotten down to where x is always equal to a number, and then we have a solution. But an equation is true for all values of the variable. It is an identity and has infinitely many solutions. Or maybe there's an equation that is not true for any value of the variable, and it has no solutions. So looking at this here, we'll show you some examples. First off, again, we need to just draw our line and start simplifying and see what we come up with. Remember to distribute or to pass out this 3 to both terms. So we're going to get 15x plus 6 equal to 15x. Now, in order to isolate the variable, I need to subtract 15x from one side so I can move the variables over to the other side. So these are going to cancel out, but as a unique situation here, these cancel out. So I'm left with 6 equals 0. Can 6 ever equal 0? No, it cannot. So there are no solutions to this equation. There is absolutely no numbers that you could put in there that are real that would make this solution true. So let's look at the next one here. Again, I'm just going to draw my line down and distribute. Negative 8y minus 2 equals negative 8y minus 2. So now I add 8y because that's the inverse. I have a negative 8y to get rid of it. I add 8y. Those cancel out. Those cancel out. And I'm left with negative 2 equals negative 2. Well, does negative 2 equal negative 2? Yes, it does. So there are infinitely many solutions for this type of equation. So, to kind of summarize what we've been working here, here's the steps for solving linear equations. Now, there's several steps, and you can use to solve a linear equation. But depending on the equation, you may not need to use all of the steps that are listed. You can just kind of go through and start, well, I don't need this one, so move to the next, or something like that. But the first one is to use the distributive property to remove any grouping symbols. The second step is to simplify the expression on each side of the equation. So get each side simplified. Combine like terms, things like that, so that they're as simplified as can be. Then you're going to need to collect the variable terms onto one side of the equation and the constant terms on the other. It doesn't matter which way. You just move one to one side, one to the other. Then you need to isolate the variable. After you're done isolating the variable, you can plug that number back in and check your solution and make sure it's correct. So now, to model it in the real world type situations, we're going to look here that a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat traveled 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? So the first thing we need to do is to understand the problem. You're given the amount of time the boat travels and the difference in speeds for each direction, and you're asked to find the distance the boat travels upstream. So we need to make a plan. So you're going to use the distance formula to write expressions that represents the problem. because the distance the boat travels in both directions is the same, you can use the expression to write an equation. So we're going to be looking at how to solve this problem. If you're thinking about it, you're thinking about the distance upstream is going to be equal to the distance downstream, right? So, let's say that we let x equal the speed in miles per hour the boat's traveling upstream. So x is going to be the speed traveling upstream. So if you're traveling x miles per hour and it took you 4 hours, that's going to be equal to, what speed were we doing going downstream? Well, it travels 3 miles per hour faster. So you've got the speed you went upstream, but you're getting 3 miles an hour faster. So that's going to be the speed going downstream per 1 hour, and it only took 2.8 hours. Well, here we're looking, our hours cancel out, so we're left with miles now. And we're going to look at that we have 4 times x, which is going to be 4x, equal to 2.8. Sorry, that's a bad looking 2. Times x plus 3. Because make sure you're remembering that you're multiplying it times that quantity. So you've got 4x equal to 2.8x plus 8.4. Now that we've got everything simplified, we need to move over the x so that it's on the same side to get our variables on the same side. So I'm going to subtract 2.8x from each side. So in this case, we're going to end up with 1.2x equal to 8.4. Now we just need to divide by the 1.2 so that we can get the all by itself. Sorry, I'm running out of room here, but those will cancel out and we'll get that x is equal to 7. So it's 7 miles per hour that the boat travels upstream. To determine how far the boat travels upstream, you're going to take the 7 miles per hour by the 4 to get 28 miles. So it actually travels 28 miles. So those are going to be your answers. So now look back to check your solution. Is it reasonable? Use the formula for distance, thinking about the speed upstream is 7 miles per hour and the speed downstream is 7 plus 3, or 10 miles per hour. When you substitute each speed into the distance formula, you get the same distance for upstream and downstream. So it is a reasonable answer. Show me your notes and make sure you do your assignment on Clever.